Good day, great listeners. Welcome to Call Science Academy. All right. If this is your first time joining our YouTube channel, watching this video right now, please try as much as possible to subscribe. All right. Click that red button, subscribe, then turn on the notification bell. All right. So today we are going into the subject physics, and we are going to treat an important topic which is called wave. We see questions on wave. All right. So if you are writing your WAEC, NECO, and JAMB, these are questions you will see. So we are going to be dealing with wave totally, and we are going to solve some questions, some exam questions, JAMB questions, WAEC questions based on this topic. So thank you very much. So now we are going to discuss this topic, wave. What is wave? Wave is a disturbance that travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium. That is the definition. Since we have understand the definition, we are going into the classification of wave. Wave can be classified based on two criteria. The first one is based on what? The medium of propagation. Then number two is based on the medium of travel. Based on the medium of propagation, we have two types of waves. We have what we call the mechanical wave, and secondly, we have what we call the electromagnetic wave. So based on the medium of propagation, we have two types of wave: the mechanical wave and the electromagnetic wave. Let us look at the mechanical wave. Mechanical wave is a type of wave that requires a material medium for their propagation. This is the type of wave that requires a material medium for their propagation. Example of that kind of wave is what we call sound wave. We have wave on a rope or string. We have water wave. And so on. The next one we are going to look now is what we call electromagnetic wave. Electromagnetic wave is the opposite of mechanical wave. Electromagnetic wave is the type of wave that do not require a material medium for their propagation. So this one don't require a material medium for their propagation. So that's why we name it, or we call it, electromagnetic wave. Example is what we call the radio wave. We have the light wave. We have the X-ray. We have the gamma ray. etc. Now we are going to look at the classification of wave based on the medium of travel. That's number 2. Based on the medium of travel, we have two types of wave. So based on the medium of travel, we have two types of wave, which are what? We have what we call a transverse wave, and we have the second one called a longitudinal wave. We have a transverse wave and the second one called a longitudinal wave.
So the transverse wave are waves whose direction is perpendicular to the direction of the disturbance or vibration causing the wave. The examples are water wave, light wave, radio wave, and so on. The second one we are going to look at is what we call the longitudinal wave. A longitudinal wave are wave whose direction is parallel to the direction of the disturbance causing the wave. So these are waves whose direction is parallel to the direction of the disturbance or vibration causing the wave. Examples of a longitudinal wave are sound wave. Sound wave tsunamic wave, and microphone wave. Of terms in wave. Alright, so these are things we are going to see as we progress. Number one is what we call the amplitude. The amplitude. And that amplitude, it is being represented using a capital A. Capital A. So what is amplitude? Amplitude is the maximum vertical displacement of a wave particle from its rest position. This is the maximum vertical displacement of a wave particle from its rest position. Some textbooks will say from its equilibrium position. Amplitude is the maximum vertical displacement of a wave particle from its rest or equilibrium position. And the SI unit of amplitude is in meter. So amplitude is measured in meter. So number two, another term, is what we call wavelengths. 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 And this wavelength is represented using a Greek symbol called lambda. This is the symbol, lambda. Alright? So what is a wavelength? This is the distance between two successful crests or trough of a wave. This is the distance between two successful crests or trough of a wave. And also it can be defined as the distance covered when a wave makes a complete cycle. The distance covered when a wave makes a complete cycle. A wavelength is the distance between two successful crests or trough of a wave. And it can also be defined as the disturbance, the distance covered by a wave, the distance covered by a wave when it completes a cycle, one cycle, vibration or oscillation. And it is measured in meter. Wavelength is also measured in meter. So the next one we are going to look at right now is what we call the frequency. The frequency. And it is represented using the letter F. What is frequency? Frequency is the number of cycles a wave particle makes in 1 second. Frequency is the number of cycles, vibration or oscillation a wave particle makes in 1 second. It is measured in Hz. Therefore, we have that frequency is equal to number of cycles all over time taken. And it can also be equal to the number of wavelengths all over time taken. So we have two ways of calculating frequency. One, frequency is equal to the number of cycles all over time taken. And also, frequency is equal to the number of wavelengths all over time taken. Please take note of this equation. Take note of this equation. Alright? You'll be seeing it in questions. So, the next one is number 4. Period. Period. Period is represented using the letter T. What is period? This is the time taken for a wave particle to complete one oscillation or vibration. This is the time taken for a wave particle to complete one oscillation or vibration. So, period is equal to time taken all over the number of cycles time taken all over the number of cycles, or equal to time taken all over the number of wavelengths. Number of wavelengths. So, period is defined as the time taken all over the number of cycles, or equal to the time taken all over the number of wavelengths. Please take note of this equation. Take notes. Notes. All right. The frequency and the period, the frequency and the period are related. The frequency and the period are related. Frequency is equal to 1 all over the period. Please take note of this. Take note of this. Frequency is equal to what? 1 all over the period. And also, period is equal to 1 all over the frequency. Period is equal to 1 all over the frequency. So therefore, frequency is equal to the inverse of a period, while period is also equal to the inverse of frequency. Please take note of this equation. Take note of this equation. The next one we are going to look at, that should be the number 5, wave speed. Number 5, wave speed. Either you call it wave speed or you call it wave velocity. Wave velocity, and it is being represented using V. It is represented using V. What is wave velocity? This is the distance covered by a wave per second. This is the distance covered by a wave per second. This is the distance covered by a wave per second. This is the distance covered by a wave per second. Please take note of that. This is the distance covered by a wave per second. It is measured in meter per second. It is measured in meter per second. Meter per second. Remember your indices. Meter per second can be written like this, meter per second, or it can be written like this, meter. You will see a superscript of -1. The x will carry a superscript of -1. So this m/x is also equal to mx bar. Please take note of it in your indices. That's where, if you don't do your indices, where you will find it difficult here, because you will see some people writing unit like this, meter per second, and seeing some people writing meter per second like this. This and this are the same thing. So it is measured, wave velocity or wave speed is measured in meter per second. So take notes. Note the wave speed. Note the wave speed, the frequency, and the wavelength are related. The wave speed, or you call it the wave velocity, the frequency, and the wavelength are related to this. Pay attention to this. How do they relate? V is equal to F lambda. V is equal to F lambda. That means V is equal to frequency times wavelength. The wave velocity or wave speed is equal to the frequency times wavelength. And recall, from what we said before, I said that frequency is equal to 1 all over what? Period, which is T. Frequency is 1 all over period. You want to substitute this into this. So remove frequency and add 1 all over period. What will you have? If I remove frequency and put 1 all over T in place of frequency, that means our wave speed is equal to 1 all over period times what? Times lambda. That's times the wavelength, which is equal to what? Wavelength all over T. Therefore, your wave velocity or your wave speed can be calculated using frequency times wavelength or wavelength all over period. Please take note of it. Take note of it. Frequency times wavelength or wavelength all over period. All over period. We are going to look at the diagram of a wave. I would like to use a diagram to describe everything that is defined here. So we are going to look at the description of a wave using the diagram. All right. So remember that the top part of this wave is called, this top side is called the crest. The crest. Here is also called the crest. All right. Here is also called the crest. So remember what I said, that the distance between two successful crests, the distance between two successful crests is what we call the wavelength. The distance between two successful crests is what we call the wavelength. All right. So this is the wavelength, and I also define that the distance covered when a wave particle make a complete oscillation or make a complete cycle is also a wavelength. It is also defined as the distance covered when a wave particle make a complete cycle. So looking at this thing now, is the equilibrium point. From here to this place is what we call the half cycle. Half cycle. From here to this particular point is what we call the complete cycle. Is a complete cycle. All right. So from this particular end, to this end is also called a wavelength. A wavelength. That's the distance covered when a wave particle make a complete oscillation or make a complete cycle. All right. Now the half of it, from this particular place to this place where the wave particle make a half cycle, it will be wavelength all over 2. All right. Remember, this is when it makes a full cycle, which is wavelength. So the half of the distance will be what? Wavelength all over 2. So if you divide this particular part, this particular half into 2, let me say from here now, from this side to this end part, you are getting quarter, which is wavelength all over 4. Wavelength all over 4. That's the distance from node to antinode, wavelength all over 4. All right. That's it. Then the distance from node to node is equal to what? Is wavelength all over 2. Node to node, wavelength all over 2. Then from a node to the next node to another next node, which makes it a complete cycle, is a wavelength itself. Is a wavelength. All right. Now remember that the maximum vertical distance, a wave makes from its rest position is what we call the amplitude. The amplitude. So the amplitude is the distance between this from this equilibrium position to the highest point, that's to the crest. That's what we call the amplitude. While from this particular position, equilibrium position, to the downward side is a negative amplitude. Please take note of that. This is a negative amplitude. A negative amplitude. All right. All right. Now we are going to solve some examples. So we are going to solve some examples based on what we just did now. So, all right. Looking at the first question. The question says the wave has a frequency of 2 Hz and a wavelength of 30 centimeter. What is the velocity of the wave? Solution. What did they give us here? They gave us, the first thing they gave us is frequency. They gave us frequency. That's the first thing. Frequency, which is F, to be what? 2 Hz. And I told you that frequency is measured in Hz, so there is no need of converting this one. The next thing they gave us is the wavelength. That's the number 2 thing they gave us, wavelength. Wavelength, which is lambda, is equal to, they say it's 30 centimeter. But the SI unit or wavelength is measured in meter. I hope you still remember. the wavelength, as I said before, is measured in meter. So we are to convert this 30 centimeter to meter. What should we do right now? Please take note that in converting it to meter, you divide by 100. You divide this 30 centimeter by 100. All right? Which is 30 divided by 100. You will get it 0.3 meter. Please, in conversion, look at how I did it. 30 centimeter. All right? Now remember that 1 meter is equal to 100 centimeter. Please take note of it. 1 meter is equal to 100 centimeter. Centimeter will cancel centimeter. What do you have? 30 meter all over 100. And that's how I get 0.3 meter. Alright? So that's it. Alright. Now, lambda is equal to 30 centimeter, which we got to be what? 0.3 meter. So the next one they are asking us is wave velocity. What is the velocity of the wave? So they are asking us of the wave velocity, which is represented with V, and wave velocity is unknown. Alright? So what is the relationship between the wave velocity, the frequency, and the wavelength? I told you from the other one that wavelength or wave speed is equal to frequency times what? Wavelength. Frequency times wavelength. Now, velocity now, substituting the value of frequency and wavelength. Frequency, they give us that frequency is what? 2 times, what is the wavelength? Wavelength is what? 0.3. So our wave velocity is 2 times 0.3, which is equal to 0.6 meter per second. 0.6 meter per second. That's the first question. This is the second question. The second question says a period pulse travels a distance of 20.0 meter in 1 second. 20.0 meter in 1.00 seconds. If its frequency is 2.0 times 10 raised to the power 3 Hz, if its frequency is 2.0 times 10 raised to the power 3 Hz, calculate the wavelength. Calculate the wavelength. So solution, what did they give us? Giving, the first one they give is the distance. The distance, let's represent it with t to be equal to what? This is 20 meter. So the distance is equal to 20 meter. What again? The time. Let's represent it with t equal to what? Equal to 1 second. It's equal to 1 second. Then what else did they give here? They gave frequency. The frequency f to be what? 2.0 times 10 raised to the power 3 Hz. Alright? 2.0 times 10 raised to the power 3 Hz. Please, before I forget, remember that this, our first question says 30 centimeter. You need to convert it to meter. But this second question says the distance, he gave us the distance in meter, 20 meter. So there is no need of converting it. Alright? Now, they gave us the frequency, and what did they say that we should calculate? The wavelength. The wavelength, lambda, is not given. It is not given. Now, look at it very well. Our V is not given directly. It's not given directly. But we can find our V, wave velocity, using the distance and time. And remember the relationship that connects the velocity and the distance and time. We say that velocity is equal to the distance all over time. If you can still remember, velocity is equal to distance all over time. Now, the distance is 20. They gave us 20 as the distance. All over, what is the time? Time is 1 second. So now 20 divided by 1 is what? It's still 20 meter per second. So this is 20 meter per second. That's V. Now, as we have gotten this V, what else are we looking for? We are going to use it incorporate with the frequency to find our wavelength. Remember the relationship that connects the wave velocity with the frequency and the wavelength. We say that wave velocity is equal to the frequency times the wavelength. The frequency times the wavelength. Now, if you want to get your wavelength, you divide both sides by frequency. Divide both sides by frequency. Frequency will cancel frequency. Therefore, our wavelength is equal to V all over what? F. The wave velocity all over the frequency. Now, the wave velocity is given to be what? 20 from our calculation. The wave velocity is 20 all over. The frequency is 2.0 times 10 raised to the power what? 3. 2.0 times 10 raised to the power 3. How can we solve this? You can use your calculator. If you use your calculator to calculate this, what happens? It will give you 10 times 10 raised to the power minus 3. 10 times 10 raised to the power minus 3 meter. In simple way, how do you do it? 2 going in 1. If 2 going to 20 to give you 10. Now, according to the law of indices, this can come up. When this comes up, 10 raised to the power 3 comes up, what will happen? It will have the inverse sign, which is negative. So this will be 10 times 10 raised to the power minus 3. So placing it where in standard form, what will you have? 1.0 times 10 raised to the power minus 2 meter, and that's our answer. It's an example 3. Example 3. Look at this diagram. This is X. This is Y. Looking at this diagram, the question says the diagram above shows a waveform in which energy is transferred from X to Y in a time of 2.5 times 10 raised to the power minus 3 seconds. What is the frequency of the wave? So solution. Looking at this now, I told you before that a wavelength is the distance covered when a wave completes one cycle. So from this cycle to this particular place is considered to be a wavelength. This is considered to be a wavelength. That is one wavelength. Alright? Now, from here to this particular place is equal to what? Another wavelength. So from here to here is 2 wavelengths. But look at this. This is not up to a wavelength. This is half of the wavelength. Alright? Adding it to this, how many number of wavelengths do we have? We have 1, alright, 2, 2.5. So number of wavelengths is equal to 2.5, or you say 2.5, 2.5, or you say 2.5. So that's the number of wavelengths. Now, the next thing we are going to look at is time. They are giving us time t to be what? To be 2.5 times 10 raised to the power minus 3. 2.5 times 10 raised to the power minus 3. Remember that I told you that frequency is equal to the number of wavelengths all over time taken. The number of wavelengths all over time taken. Number of wavelengths all over time taken. So substituting, we have that F is equal to, what's the number of wavelengths here? Number of wavelengths is 2.5. 2.5 all over. The time taken is 2.5 times 10 raised to the power what? Minus 3. 2.5 times 10 raised to the power minus 3. So what do we have? 2.5 divided by 2.5. If you use your calculator very well, times 10 raised to the power 3. Times 10 raised to the power 3. This is in days. 1 times 10 raised to the power 3. Alright? This divided by this will give you 1. This coming up from the law of indices will give you positive 3. That should be 1 times 10 raised to the power 3 days. That's the number 2 question. This is question 4. Right? The question 4 says the figure below represents displacement time graph of a traveling wave moving with a speed of 2 meters per second. Moving with a speed of 2 meters per second. So this is the diagram. Alright? This is the diagram. So now the question says determine from the graph the amplitude, 2 period, and number 3 wavelength of the wave. So solution is very, very simple. Amplitude, which is represented using A, is equal to, what did I define amplitude as? I say that amplitude is the maximum vertical displacement a wave particle makes from its rest position Alright, so this is the rest position. This is the maximum vertical displacement of that particular wave. So to rest it to this graph right now, what do you have? You have 0.2. So 0.2 is the highest. So our amplitude A is what? 2 meter. Please remember. So this is the highest vertical displacement. This is the amplitude, the highest vertical displacement. Alright, now the next one we are going to look at is what we call a period. The period, alright, T. From the definition, what did I say that the period is? I say that a period is the time taken for a wave particle to complete one cycle or to complete one vibration, or you can say to complete one wavelength. Alright, so this is the time taken for a wave particle to complete a cycle. And remember, this particular wave completed a cycle, and the time there is what? 0.1. So 0.1 is the period. Alright, 0.1 is the period. 0.1 is the period. Remember, what's the SI unit of period? It's in seconds. Alright, it's in seconds. And why did I say that it is 0.1? Because it is the time taken for that wave particle to complete one cycle. Please take note of it. Thank you very much. Then number three, they say wavelength. Alright, lambda. Now, what is wavelength? From definition, we say that wavelength, remember, we say that wavelengths, we say that V is equal to F lambda, right? And we also say that V is equal to lambda all over what? T. So V is equal to what? Lambda all over what? T. Now, they are giving us V. They are giving us V to be what? 2 meter per second. Alright? 2 meter per second. And your T is given to the 0.1 seconds. Your T from period, from the graph, is given to the 0.1 seconds. Your T is equal to 0.1 seconds. Now it's very, very simple. Your V is equal to lambda over T. Therefore, your lambda, which is the wavelength, your wavelength is equal to V times T. V times T, that's the wave velocity times the period. Therefore, the wavelength is equal to what is wave velocity 2 times what is the period 0.1. Therefore, your wavelength is equal to 2 times 0.1. 2 times 0.1 will give you 0.2 meter. Alright? Therefore, your wavelength is equal to 0.2 meter. Please take notes. Take notes. It's very, very simple. It's very, very simple. So if you see this in your exam, this is actually past question. This is a past question. All the questions I've been solving is a past questions. JAMB, WAEC, and NECO. I picked it up from here. Please take notes. Take notes. Take note of it. Thank you. We are going to look at wave equation. So the vertical displacement covered by a wave is given by y equal to a sine 2 pi x all over lambda, 2 pi x all over lambda minus wt. Alright? Minus wt. Let me say this is equation A. Alright. Now, we are going to look at wave equation. So the vertical displacement covered by a wave is given by y equal to a sine 2 pi x all over lambda, 2 pi x all over lambda minus wt. Alright? Minus wt. Let me say this is equation A. Alright. Now, where y is equal to vertical distance covered by the wave. Vertical distance covered by a wave. And it is measured in meter. Remember, it is measured in meter, not the SI unit. Now, RA, this capital A is equal to the amplitude, which is measured in what? Meter, right? This one is measured in meter, right? The short form is M, or the symbol. Now, normal, your pi, this is your pi, which is equal to what? 22 all over what? 7. Alright? Then, your x is equal to the horizontal displacement. Horizontal displacement. The horizontal displacement covered by the wave. And it is measured in what? Meter. M. Lambda, which is the wavelength. This is what? The wavelength. The wavelength. And it's measured in what? In meter. Then T is equal to the time. And time is measured in what? Time is measured in seconds. Time is measured in seconds. Alright? This is measured in meter. It's measured in meter. Then the next one is what? W. This is called omega. Omega. Right? This W represents, omega represents angular velocity. Angular velocity. Alright? And it's measured in rad per seconds. Rad per seconds. Alright? Now, from your circular motion, this W have a value. Recall, your W is equal to 2 pi f. Remember, from your angular velocity, from your angular motion, your W is equal to 2 pi f. Alright? Let us call this equation B. This equation A, equation B. Now we are going to substitute equation B to this equation A. So we are going to take the value of W to this particular place. So instead of writing W, you will replace it with 2 pi f. Alright? If you substitute it by substitution, what do we have? We have that our y is equal to a sine 2 pi x all over lambda minus, instead of W now, we replace it with 2 pi f. 2 pi ft. 2 pi ft. Please remember this equation. Remember this equation. Remember this equation. This equation becomes the wave equation. Please remember this. This is the wave equation. We are going to be solving some calculation based on this. We are going to solve some calculation based on this. Alright. This is the first question. This is the first question from the wave equation. And this question says a plane progressive wave is represented by the equation y equals to 2 sine 2000 pi t minus 0.5x minus 0.5x, where the symbol have their usual meaning. Where the symbol have their usual meaning. They say that we should calculate first the frequency of the wave, the number 2, its amplitude, and finally its wavelength. So solution. Alright, so we are going to write out the equation, the main equation from the question, and the main equation is y equals to 2 sine bracket open 2000 pi t minus 0.5x. Alright, so this is the main equation from the question. This is the main equation from the question. Now, they said we should use it to calculate the frequency of the wave, the amplitude, and the wavelength. We are going to compare this equation to the equation of the wave I gave you before. Now, looking at it, the equation of the wave is equal to y equals to the amplitude, which is A, sine 2 pi x all over lambda minus 2 pi ft. All right, we are going to comparing. There are things I want you to note here. There are major things I want you to note here. If you look at this particular main equation, that's the equation of the wave, you will see that where x is, that's where you see your lambda, that's where you find your wavelength, and where your t is, that's where you find your frequency. Note this, where your s is, that's where you find your wavelength, and where your t is, that's where you find your frequency. So if they ask you for wavelength, you will be looking for that particular part where you will see x. So that particular part you see x is what you will use to compare with the equation of the wave. And if they ask you to find the frequency, you will be looking at where you see t, because at that particular place where you see t, that's where you find your frequency. Because in the equation, they may interchange the variables. So this is the trick I want you to use to note it. Now, since I said the amplitude, the frequency of the wave, the frequency. Looking at this and this now, this is the frequency. Which one contains the frequency? This, right? And remember, when you are writing it out, the sign does not matter. The sign does not matter. You will not come and write minus 2 pi ft. No. You will just write 2 pi ft. Alright? The sign does not matter. Equal to, now you are going to compare it with the equation given to you in the question. You are going to compare it with the equation given to you in the question. Now look at this particular place. I told you that where you see your t is likely where you see your frequency. That's where you see your frequency. So if you look at this now, we have 2000 pi t minus 0.5x. Alright, so where you see your t now is this 2000 pi t. Alright, that's the one you use to compare with the one that contains the frequency. Let me repeat myself. I said, when you are asked to find the frequency, look at where you have your t. That's the one you use in comparing with the frequency. If you are asked for wavelength, look for the one with x. That's where you use the one you use to compare for your wavelength. Alright, because they will interchange it. They may interchange it in the questions. Like this question we have now, we have 2000 pi t. This 2000 pi t would have come to this end, while 0.5x would have been at this particular end. So they interchange it. If you are not wise enough, you will go and use 0.5x and compare it with 2 pi ft, and you will get the wrong answer. So use these techniques. Whenever you are asked to find the frequency, look out for the one that have the x and use it to compare, use it to equate with the main equation. Whenever you are asked to find the wavelength, look at the one with x in the main equation to solve for a wavelength, and whenever they ask for frequency, look at the one with t to equate with the main equation to get your frequency. So since we are looking for our frequency right here, which is 2 pi ft, which one are we going to use? Is it 2000 pi t or 0.5x? Now, from what I told you, 2000 pi t is the correct one to use. So we have 2000 pi t. Alright? So 2 pi ft is equal to 2000 pi t. So what's the next thing you need to do? Since you are looking for the frequency, any other thing that is beside frequency should be eliminated. So divide both sides by any other thing that is being attached with frequency. So we divide this by 2 pi t. Alright? Divide both sides by 2 pi t. 2, we go with 2 pi, go with pi t, go with t. So your f now is equal to, remember that your f now will be equal to 2000 pi t all over 2 pi t. 2000 pi t all over 2 pi t. Alright. Remember that this t, we cancel with this t, pi we cancel pi. Alright, what do you have now? You have 2000 divided by 2. 2000 divided by 2 is what? 1000. And what is the unit of frequency? The unit of frequency is, frequency is measured in Hz. So you have 1000 Hz. 1000 Hz. Alright, the second one is, they said the amplitude. The amplitude amplitude. The amplitude. All right, A. Now, if you look at this now, comparing the main equation with the equation, look at the amplitude here. When we want to compare it with the equation given in the question, which one is the amplitude? Looking at this, we have two sine, all right, and the equation of the WAEC says A sine. So we are going to compare this to this. Now, anything that comes before sine is your amplitude. Please take note. Anything that comes before sine is your amplitude. So comparing, you have that your A is equal to what now? Your A is equal to 2 meters. So your amplitude is equal to 2. Your A is equal to what? 2 meters. So your amplitude is equal to 2. Please take. Now, the third one is the wavelength. The wavelength. The wavelength. Alright, the wavelength, which is the lambda. Now, looking at the equation of the wave, which one contains the wavelength? This is it, right? So you are going to use this one and compare with the equation given to you in the question. Alright, now remember what I told you before. Wherever you see your x, that's where you see your lambda, or that's where you see your wavelength. That means wherever I see my x, I will use it to compare for my wavelength. What do we have here? We have 2 pi x all over lambda, 2 pi x all over lambda equal to, what are we going to use to compare with the main equation? We are going to use 0.5x. 0.5x. Alright. Now the next thing we are going to do is to cross multiply. You want to make lambda the subject of the formula. You want to make lambda, which is the wavelength, the subject of the formula. We cross multiply. When we cross multiply, we have 2 pi x times 1 equal to 0.5x times lambda times the wavelength. So all these times 1 will give you 2 pi x equal to 0.5x lambda. So right now we are looking for lambda. What do? You divide both sides by anything that is being attached with lambda, that is being attached with wavelength. So you divide this side by 0.5x, divide this side also by 0.5x. Alright, what do we have? 0.5 will go with 0.5, x will go with s, leaving you with lambda. Alright, this particular place, s will go with s, having that your wavelength is equal to 2 pi all over what? 0.5 is equal to 2 pi all over 0.5. Right? Now, remember the value for your pi. Your pi is 22 over 7. Alright? So, using your calculator, 2 pi divide by 0.5. What do you have? You have 12.6 meter. 12.6 meter. And that's your what? Your wavelength. That's your wavelength. Right now, this is the second question. The second question says the equation of the wave traveling in a horizontal direction is expressed as y equals to 15 sine 2 over 3. 2 over 3 bracket open 62 minus x bracket close. He said, what is its wavelength? So if you see this kind of question, what are you going to do? Because the one we solved the other time, do not have anything before the bracket after the sign. Alright, so what do you do? It's very, very, very simple. It's very, very simple. You use this and multiply this and this. Use 2 over 5, multiply 60t. Use 2 over 5, multiply x. So what do? Rewriting this equation, you will have that y is equal to 15 sine. 15 sine 2 over 5 times 60, that's 2 times 60t. We give you 2 times 60 will give you 120t all over what? 5. Then minus 2 over 5 times s will give you 2x all over 5. Bracket is closed. Alright? From here now you know what to do. They said what is the wavelength? So calculating wavelength, for wavelength, which is lambda. Lambda is not given. So for wavelength, I told you that the main equation which is y equals to a sine 2 pi x all over lambda minus 2 pi ft. I told you the other previous question, I told you a technique that we use, that wherever you find, if they are asking for frequency, wherever you find your t, that's where you find your frequency, and wherever you find your x, that's where you find your what? Your wavelength. So looking at this right now, they are asking for wavelength. So we are going to use this particular one, which is 2 pi x all over lambda. All right, we are going to use it and compare it to, which one are we going to use now? From what I told you, which one are we going to use? Remember where x is, that's where you find your lambda. So looking at these two variables right here, what are we going to use to compare with this? We are going to use 2 over 5x because that's where we find our lambda. That's where you find your x. Remember I told you, look out for where you find, for where x is, that's where you find your lambda. So in comparing now, we are going to compare this with this. Remember I told you that negative sign does not matter, it doesn't matter. Alright, so this will be compared to this. That's 2 pi x all over lambda will be equal to 2x all over what? All over 5. So what do? You cross multiply. You cross multiply. What do we have? You have 2 pi x times 5 equal to 2x times lambda. Alright, so 2 pi x times 5 will give you 10 pi x. Alright, to give you 10 pi x equal to 2x lambda. So I want to get my lambda. What do? Divide both sides by 2x, divide this side also by 2x. Alright, 2x becomes 2x, remaining lambda here. Alright, so x will go with x, 2 divided by 10 will give you 5. What do you have left? You have 5 pi. Remember that our pi is 22 over 7. So if you calculate it, 5 times 22 over 7, which is 5 pi, it will give you 15.7. 15.7 meter. So that's it. Then your assignment is this. From this question, I want you to give me the answer for the amplitude and the answer for the frequency. The answer for the amplitude and the answer for the frequency. Please drop it on the comment section. Please try as much as possible to like, to subscribe, and also turn on the notification bell so that you will be alert, so that you will receive the alert when new video is being dropped. Thank you very much. Remember, this is Crow Science Academy.